Yes, hello. I'm going to do a recording over 10.6. Their equations with radicals. Hang on, I'm trying to annotate and get set up here. Okay. Oh, this isn't working. Hang on. There we go. So you see how this original equation has a radical. Now I'm starting here with number 4 because once you do number 4, you can do them all. So the steps, first step is always isolate a radical. Now sometimes they have more than one. I have to write at an angle. But sometimes they have more than one radical, so you have to repeat this process. But in this case, we're going to stick with pretty basic. Excuse the noise in the background. My dog is tiptoeing around. My child is watching a video and laughing. So anyway, distraction-free is not happening this semester. Okay, so first we're going to isolate a radical. What do we have to do? We got to get rid of that. You see how this piece over here is not radical, so we need to get rid of it. What do? We add it to both sides. Then you have a square root of 6x minus 5 equals 7. So that was step 1, isolate the radical. Critical, have to do it. Step 2, we're going to use the power rule. And that is, there's this rule when you have an equation with radicals, so whatever you do, if you square it on one side and you square the other side, you'll get, the solutions will work. So what we're really trying to do is bring that thing out from under. So we're going to square this. So you see that, because that 2 on the outside undoes that index, and the 6x minus 5 will come out. Well, whatever we do here, we have to do here. So now we're going to have 6x minus 5 comes out. This is from the old stuff, you know, the nth root of a to the n, even whether that n is under or outside here, you see, it's still the a comes out. So, and then you have a 49. And then you just solve. So you use the power rule, meaning if it's a cubed root, you cube each side. If it's the 5th root, you take each side to the 5th power. This semester, we're doing this just a little shorter, so I'm not going to go into great details and very long ones. So we're keeping it fairly basic. But so first you isolate the radical, then you use the power rule. Then you solve just like you would any other day. Sometimes you have to use quadratic, sometimes you have to use just linear solving. So in this case, you have x to the first, all you do is isolate the x. So you need to add 5, right? And I'm showing the basic steps that I don't usually show anymore at this point. Then you have a 6x is, what is this? 49 plus 5 is 54. Gosh, I hope basic math doesn't get me right now. And then you have x is 54 over 6, which you can then simplify into a 9. And then, so we solved, and then we're going to check any proposed solution in the original, okay? So meaning, if it starts out radical, you have to make sure that it'll cause a true statement if you plug it back into the original, and this is actually mandatory at this point. Check any proposed solution in the original. So let's see, and you'll see later why that is mandatory. Students have a hard time doing that because we tend to take shortcuts when we're checking because we run out of time. Well, you can't do that anymore, not in the radicals. But so let's check. The original says square root of 6 times 9, x is 9, minus 5, and then be careful, this is a minus 7 out here. And this has to equal 0. So 6 times 9 is 54 minus 5. Then that minus 7 is outside the radical, still critical. Square root of 49 and 7 minus 7 equals 0, true. So yes, in this case, final answer in solution set is 9 or x equals 9, final answer. But you do need to check, okay, this is mandatory. And anytime you have a radical to begin with, it's mandatory. Okay, so I repeat myself a lot, but I'm trying to make some points that are critical where students get a lot in trouble a lot, you know. So I'm going to clear drawings. I'm going to move around now. Now we're going to do a couple of the easier ones. Excuse me while I move around on my paper here. Let's do this one. Okay, so 10-6, this is how it starts in your homework. Because we're going to do 10-7 too, but not on this video. Okay, so here, isolate the radical, already isolated, not a problem. Then you say, I'm going to use the power rule. So then you say, okay, if I square this, the root is undone, or, you know, the 5x comes out. Whatever I do to the left, I have to do to the right. So you're going to have a 5x equals 5 squared is 25. Then you say x equals 25 divided by 5 is 5. Then you need to check it in the original. So 5 times x is 5. Does that equal 5? Square root of 25 equals 5, true. So final answer, x is 5. Next one, you know, and it gets a little bit old. I might not finish every single one of those. So you would immediately use the power rule. So you get x minus 9 is 25. And then you say x equals, add 9, 34. And then you ask yourself, is it true in the original? Square root of 34 minus 9, does that equal 5? Square root of 25 equals 5, true. So x is 34. So these beginning ones, they're fairly basic. Oh, I'm trying to move around. Okay, so it's difficult to scroll within here when I'm working in Zoom and using annotation. Okay, now let's try this one. Isolate the variable. So isolate the variable, isolate the radical. So this, you see how the radical is already isolated. So then you say, okay, now I'm going to use the power rule. So I'm going to square this. And I'm going to square this. I wonder if this is not, I didn't do the draw piece. I meant to make that blue. So the 2x comes out. And then a negative 10 squared is a negative 10 times a negative 10, which is 100. Then you get x is, this is funny writing, 100 divided by 2 is 50. So x equals 50. Now let's check this. My son's getting ready to turn off his video that I just turned on, so I might have to pause. Okay, square root of 2 times 50. Does that equal negative 10? Square root of 2 times 50 is 100. Square root of 100 is 10. 10 equals negative 10, false, right? So if this is false, you're going to have to say that is not an option. X cannot be 50. Just a second. I'm going to pause for. Okay, I'm back. I hope I'm recording. Okay. So when you have a radical, the reason it's critical to check is because you might have some extraneous roots. That's what they're called. But that's where, because this is never going to be true, this here. And you could just memorize, hey, if you have an even root and you have a negative over here, it's impossible, you know, this is impossible. But if it's an even root, meaning in this case it's a square root, you know, or if you have a fourth root, then it's impossible because nothing negative is going to be able to come out. So, but this is why you don't really have to memorize that part. You just have to always check your work, and then you don't have an issue with this. So let's see. Let me see what else we have. This one here, what do? First thing you do is isolate the radical. So you move your 7 over, it's not an issue. Let me find one, like here, for example, number 6, you know, you isolate your radical. So what happens? You subtract 8, well, then you have an even root and a negative over here, or you can go ahead and solve it. But this one is actually going to be another one of those. The 9x plus 7 comes out, and negative 8 quantity squared is 64. Then you have 9x equals 50. Oh my gosh, I can't do basic math right now. 7. And then you have x is 57/9. And it's not a problem that this is a fraction. The problem is that if you plug it in, and don't let the fraction part scare you, that's not an issue. The 9 times 57/9, you see, plus 7, this is original radical, and then you have a plus 8, and you're asking, is this true? Always plug it in the original. When this is over 1, technically, right, wouldn't they just cancel? So you get 57 plus 7 is 64. And does 8 plus 8 equal 0? You see, this is false. So it's another one of those. One thing, I don't want you to always automatically say trash, you know, like if you see a negative, like I want you to think about this for a second. What if you had something like, oh, go away box. You know, and I'm just making one up right now real quick. Like some students see this and then they say, well, I see a negative over here on the right, then it's trash. Well, not really true. You need to always isolate the radical first before you think about that, you know, so you'd add 4, and then you end up with a positive on the right side. You can certainly solve that. So just don't assume anything. I say solve them the way they're intended and then check them in the original, and then you won't have an issue. Okay, this one here needs to be addressed real quick before we do the triangle. Okay, step 1, isolate the radical. Okay, already done. Then you use the power rule. And then this is where this thing keeps happening over and over in chapter 5 and chapter 7. Over and over, students do the same thing. Okay, so you say 37 minus 6x comes out. That's not a problem, good job. The problem is the right side usually gets butchered. What is x minus 5 quantity squared? And this is in the classroom where I yell it over and over and over. But a minus b squared is never a squared minus b squared. Okay? I'm going to tell you, you need to FOIL. Either FOIL or use the formula. And one more time for the semester. X minus 5 squared is really x minus 5 times x minus 5, which is really x squared minus 5x minus another 5x. This is that FOILing. And then the last is a plus 25. Or you can use the formula, which is a minus b quantity squared is a squared minus 2ab, if this is a and this is b. We've done this many times, which is why I don't go over it that fast, that slow. A squared minus 2ab, you know, take the a times the b and double it, plus b squared. And b is 5, so it's 25. You see, so no matter which way you do it, you're going to get the right thing as long as you don't just square each item. you need to either FOIL or use the formula. Now you have a quadratic. So now if you want to solve a quadratic, you're back in at the end of chapter 5. No, chapter 6. So how do you do this? You don't want to move your x's to the x squared to the left because that causes a negative x squared. Why don't you just move everything to the right? So you're going to add 6x, and then you're going to subtract 37, 0 equals x squared minus 4x. Ugh. Negative, sorry, I have to do this stuff. I can't do basic math right now. 37. I'm looking for a mistake, so just give me a second. I have my moments too, you know, like we're human beings, remember? It has to be a 12. I'm sorry. I'm going about this all wrong. So you caught me again. Oh well. 37 minus 25 is, I'm being really silly. Okay, so now I can factor this. It's a simple trinomial, so you open, close, xx. You have a product of negative 12 and a sum of negative 4. How about a negative 6 and a positive 2? So I'm back to normal, but I have my basic math moments. So this is correct, negative 6 times 2 and negative 6 plus 2, okay. So then you solve each one of those. This is all still chapter 6, so x is 6, or x plus 2 is 0, x equals negative 2. And this is why, if I prepared this ahead of time, I would spare myself from any embarrassing moments, but you know, we are humans and it's okay to once in a while have a moment. As long as you fix it before it's due, or you know, on a test, I would use a calculator if I had a moment. So now we need to check each one of those. I'm gonna change color real quick. So I said this was gonna be a quick video, and here I'm taking forever. Okay, we're gonna check over here. I'm trying to change it to green. Hope it won't let me change colors. Nope, I don't understand it. It just won't change. It just will not let me change colors. Okay, I'll deal with it. So in the original, 37 minus 6 times 6, if I use the 6 first, is equal to 6 minus 5, question mark. 37 minus 36, the square root of 1 equals 6 minus 5 is 1. That is true. Now let's check the negative 2. 37 minus 6 times negative 2 is negative 2 minus 5, question mark. 37 plus 12. And then right here, you might notice that it doesn't matter what the left thing is. It's never going to come out as a negative because it's an even root. Square root of 49 is not negative 7. So then you have to throw this one in the trash pretty much. Causes an extraneous root and you only have one answer. Okay, but don't always throw the negative one in the trash. It depends on the problem. Depends on the original. Okay, so real quick, the Pythagorean theorem, we need to talk about it real quick. Oh no, I'm gonna make you deal with those a little bit. I grabbed stuff out of the homework. Okay, find the length of the unknown side of the triangle. Clear all drawings. You see, I'm not. Here, it's in drawing. Okay, just a second. Why can I not? There. Okay, There, now I have my color. Ooh, this is not pretty handwriting, sorry. I'm in a hurry. I'm trying to get this done for you. A squared plus B squared equals C squared. If you have a right triangle, C is always, though, the hypotenuse, okay? So the longest one is always the hypotenuse. So, so we're gonna call this a B. And let's not worry about the m's, that's just meters, but according to the Pythagorean theorem, A, let's call this A is 4 and then C is 12. So we're going to replace the A squared with 4 squared plus B squared, because that's an unknown, equals C squared. So then you have 4 squared is 16 plus B squared, that's not a 6, okay, is 144. Then you have B squared equals, because now you're gonna, actually, we can do this one with the square root. Have we done that already in this class? We've done it factoring too, but let me look at that. 144 minus 16. Okay, so then we're gonna do the, we're gonna have to do the square root method. So now we're gonna take the square root and the square root, and then we have to do a plus minus, but you know, this isn't until 11.1 that we're doing this. Hang on, I'm trying to think. This is one way to do it, but you haven't learned this yet, which concerns me just a little bit. It doesn't really matter. In 11.1, I believe it's in 11.1, you're gonna learn that you can take the square root of both sides. That makes that square disappear, and the B just comes out. And then you have to do a plus or minus. The rule is if k squared equals, or if x squared equals k, let's say, then x equals plus or minus the square root of k. That's some constant, and I should have used x in the beginning. But so does it matter if it's a minus? In this case, yeah, totally, because you can't possibly have a negative measurement. So we can ignore this rule with the plus minus for right now. We can just take a square root of 128. Then we have to take the 128. You have a calculator. I don't, obviously. 128 is divisible by 2. 2 times 64. And then 64 is an 8 squared. What that means is if you took your time and did this, what comes out, what stays under, we did this the other day, the 8 comes out and the 2 stays under. And then the this piece here is 8 square root of 2 meters. So in the next one, I'm just gonna draw a real quick sketch and then you're gonna handle this. Don't be afraid of words. So a spotlight is mounted on the eaves of a house 20 feet above the ground. A flower bed runs, oh my gosh, that's a lot of words. Usually we run for the hills, you know? But what we're gonna do is attack this thing, and we attack it by drawing a picture. Okay, I have a house. The spotlight is 20 feet above the ground. Whoa. So here's the eave of the house. You know, this isn't gonna be pretty. Whoa. And this here is 20 feet. And then we have a flower bed runs between the house and the sidewalk. So the closest the ladder can be placed to the house is 15 feet. So Here's your flowers. And this thing here is 15 feet. Okay. And flower bed runs between the house and the sidewalk. The closest the ladder can be placed to the house is 15 feet. So here's more flowers. But you know, for a visual, okay, how long a ladder is needed so that an electrician can reach the place where the light is mounted. So we know this thing here is 20. And what are we trying to find? We are trying to find this piece here. Because how long is the ladder is needed? So here's your ladder. The blue is the ladder because the electrician has to reach the light. Okay, so in a triangle, you know, the hypotenuse is, in this case, usually we use a C for it. You can use an X, you can use an A, it doesn't matter. And then we know this is 20 and this is 15, and then you use the Pythagorean theorem. So in this case, a squared plus b squared equals c squared. As long as you have the hypotenuse on the right, you're in good shape. Well, in this case, that's automatic. And it doesn't matter which one or the other, you see, and then you solve. And then number 9, the formula gives the velocity, blah, 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 if an object after it falls. That's a lot of words. I'm not running for the hills. I'm going to attack. And what I'm going to do is just plug in stuff. So please keep this stuff simple. It's really not meant to be that complicated. This is your formula. They are telling you, it tells me that G is gravity is 32 foot per second squared. So you plug in 32 for the G, and then velocity is 160. So you replace this with the 160. You replace the G with 32, and then you simply solve for the H, you see? So don't make this worse. How far has an object fallen? So you want to know what is the height. So anyway, this is it. Sorry, it's just in places I kind of lost it. That's okay. But we finished, and now I'll probably take a break before I do the next one because I've done better work than this before. Thank you.